So now that we've talked about cytochrome C being removed from the mitochondria, we can talk about what happens to it when it's outside. So cytochrome, when it's released, cytochrome C when it's released, binds to proteins called APF1s, and it activates them. It causes the APF1 to hydrolyze its bound ATP to an ADP, and this reveals the CAR domain of the APAF1, right? And with these CAR domains released, they can form aptosomes by having all the CAR domains associate with each other. So it forms these aptosomes by having the ADP that was now bound to this APAF1 turn or get switched out for an ATP. So now all these guys are ATP bound. Sorry for the crudeness of the drawing, but that's what happens when you're not an art major. And the aptosome now, in this form, can recruit procaspases. And these procaspases also have CAR domains, and they associate with the middle center. And these procaspases can now go and cleave executioner caspases. And cleaving executioner caspases leads to a cascade as more and more caspases cleave each other, and this cleavage will then eventually lead to apoptosis because executioner caspases, they cleave specific molecules that are needed for apoptosis. So again, apoptosis, my favorite little cutout, it's going to happen through this same pathway.